Continuing on with the bell curve, we are going to use the 68, 95, 99, 7 rule to complete each problem. Now, the first thing we are going to want to do is create a bell-shaped curve with the given mean and standard deviations to help us identify the given values or the data values we are searching for. So for example 1, it says suppose the height in inches of men 20 to 29 years old in the United States are normally distributed with a mean of 69.3 inches and a standard deviation of 29.2 inches. Find each of the following. So, what information do we need? Well, we know that the mean is 69.3 inches and the standard deviation is 2.92 inches. So we are going to take that and we are going to use it to create our bell curve. Okay, start by drawing our straight line. And we probably want that a little bit higher. And we are going to label. Okay, so down the center, we know we have our mean, 69.3. To the right, we are going to add one standard deviation. So 69.3 plus 2.92 gives us a total of 72.22. Then we are going to take the next one, add two standard deviations, and that is 75.14, and add your third standard deviation, which is 78.06. Okay, so that's 3 standard deviations above the mean. Then we are going to do the same thing over on the left side. We are going to subtract 1 standard deviation, 69.3 minus 2.92 gives us 66.38. Subtract 2 standard deviations, that's 63.46. And subtract 3 standard deviations, that's 60.54. So we have created our number line, right? And because our mean is in the center, remember that's where the mound is, comes down to a tail. Opposite side comes down to a tail. Okay. Now, if you want to make things a little bit easier, you can always split it off into our percentages per section, right? And I think personally that's just a little bit easier when you're looking for data. So from the previous part of the lesson, we know that each of these is 34%, 13.5%, 2.35%, and anything beyond 3 standard deviations is 0.15%. All right, so we're going to use this table to make predictions about the data. So first of all, it says the percent of men that are between 63.46 inches and 75.14 inches. So we're looking at all data, and symbolically, it would look like this. 63.46 less than x less than 75.14. So we take a look at those values. 63.46, 75.46. How much data is in this area? Add those percentages all together, or actually just by looking at the bell curve, you should know. 2 standard deviations above and below means that 95% of our data is within those values. Okay. For C, the percent of men who are taller than 72.2 inches means we're looking at data that is greater than 72.22. Looking at our bell curve, we're looking at this portion here. So we know that by adding this, we get a percentage of 16. So 16% of our data falls above 72.22 inches. All right, for D, you can see that those values indicate 3 standard deviations above and below our mean. So according to the 68, 95, 99, 7 rule, that tells us that 99.7% of our data lies within 3 standard deviations. Okay. For example, E, you're looking at men who are shorter than 60.54 inches. So being that that is our third standard deviation below the mean, we know that anything past that point would fall into the 0.15%. Okay. So not too bad. All right, go ahead and hit the pause button and try example 2. You are drawing the bell curve for A, and you can go ahead and draw it over on the side if you printed this, or on your own paper. You guys have plenty of space, I would imagine. Okay, so try A, drawing the bell curve, and then answering the questions B and C for the bell curve. All right, this is what you should have for example 2, right? Looking at your bell curve, your mean in the center is 57. Adding 1 standard deviation is 79,000. Then adding 2 standard deviations is 101,000. And adding 3 standard deviations is 123,000. Going in the opposite direction, which means we are subtracting that standard deviation, you get 35,000, 13,000, and then we have negative 9,000. Which, if you think about this, right, being a lieutenant governor in the US, there is no way they would make less than $9,000. That means, or sorry, make negative $9,000. This would mean that they are paying the government to be a lieutenant governor, which does not happen. Okay, so this is kind of our um, a mathematical error, if you will. This would never happen. Okay, so when we look at this data, for B, you were asked to find within what range does 95% of the salary fall. Well, remember, within 2 standard deviations, we have 95% of the data. So in this case, between 13,000 and 101,000 would be the salaries, the governor's salaries. Okay. And then for C, about what percent of the lieutenant governors have an annual salary between 13 and 79? Well, that's 2 standard deviations to the left and 1 standard deviation to the right. And if you add these all together, 34, 34, and 13.5, you get a total of 81.5%.